Hello everyone, I am Mohammad Hassan Khan and this is the first task of Spark Foundation internship. Task linear regression task number 1. In this part, we import the libraries, different libraries. First one is linear regression library, second is pandas for data frame, and third is numpy for numbers. And this and this is for visualization libraries. And the last one is mean square error to evaluate our model. In the second part, we load the dataset from URL, and in the third part, uh, we go to the exploratory data analysis. Data had showed the 5 rows of our dataset, and you see that in our dataset 2 rows, 2 columns, R's and scores. Data shape tell us the number of rows and number of the column, and data describe tell us the mean, standard deviation, minimum, first quartile, second quartile, third quartile, and maximum value of each column of each continuous column. And in this step, data.info, you see that first one is float, second one is integer, and data.apply lambda is the function, is the also the technique to finding the null values in our data set. In this part, we plot a scatter plot between two continuous variable r's and scores, and you see that uh, r's is on the x-axis and score is on the y-axis. Data dot column is the number of columns in our dataset, and this is correlation technique between two continuous variable, and you see that r's and scores has strong correlation technique 0.976. R's and scores 0.976. R's and R's is 1. R scores and scores is 1. Then in the next stage, we plot a heat map, data correlation heat map, and you see that R's and scores is 0.97 in relationship correlationship, and you see that R's and scores 0.98, approximately 0.98, and show that 0.98. Correlation is the relationship between two variables. Sometime correlation in positive, sometime correlation negative. In this part, we split our data set. Y is our scores and X is our R's. Why we uh, score assign Y into the why we score assign to the Y variable, because we want to predict scores. In this part, um, we split our data set in two parts: test data set, test data, and train data. Test size 0.2, it means that we train our model 80% data set and test our model 20% of data set. Then we create and fit our model. We create the model and fit X train and Y train. Then our model print the intercept and slope value. If you see that M is the slope, B is the intercept, 9.1, 9.91, and intercept is 2.01. X represent R's and Y represent score, because we want in the above I say that we want to predict score. That's why score in that position. In this part, we predict the scores. We predict the test data set, And in test dataset, we have test data with the help of we predict some values 16, 33, 75, 26. This is scores which our model predict. You see that actual value of our scores is 20, but our model predicts 16.88. Actual value is also 27, but our model predicts 33, and so on. It means that our model is not so good, but accuracy score is good. Uh, and in this part, we plot a line. We plot a line in which our model predict. This is the line which our model predict, but the actual value is this. And the difference between point and the line is the residuals. This is the negative residuals and above is the positive residuals. And in this part, we predict the score above given hours. 9.25 is the hours, and we predict the score on 9.25 hours. So number of hours is 9.5, and our model predict the scores 93.69. This is the mean square error. Why we use this? Mean square error tells you how close a regression line is to set of point. This is a 21.59. It's so much big. It means that our model does not well. That's why it's so much big. A mean square error is less than 2 1, and is the if we have mean square error is less than 2 and 1, it means that our model perform well. But in you said you see that mean square error is 21.59. It means that a lot of difference between actual and predicted value. Thank you so much. This is my first linear regression task.